Hello students, now we will continue this topic sequences and series part 5. Now we will do today the four questions. First question is the sum of n terms of an arithmetic progression are in the ratios 5n plus 4 ratio 9n plus 6. Find the ratio of their 18 terms. Next question, if the sum of p term of an AP is equal to the sum of first q terms, then find the sum of first p plus q terms. Next question, sum of the first p, q, r term of an AP are a, b, c. Respectively, prove that a upon p q minus r plus b upon q r minus p plus c upon r p minus q equal to 0. The ratio of the sum of m and n term of an AP is m square and n square, so that the ratio of mth and nth term is 2m minus 1 ratio 2n minus 1. So these four questions we will do today. Look here, first question is the sum of nth term of an AP are in the ratio 5n plus 4 and 9n plus 6. Find the ratio of their 18 term. So look here, we will suppose here first AP, here first term is A and common difference is D, and second AP, first term is capital A, common difference is capital D. Now we know the sum formula. Here what is given, sum of n term of first AP and upon sum of n term of second AP. This is n by 2, 2a plus n minus 1 and d. Sum of the second AP n by 2 to capital A plus n minus 1 capital D. And this ratio is given to us 5n plus 4 upon 9n plus 6. Look here, n by 2 we can cancel, and the left hand side divide numerator and denominator by 2. We can divide by 2. So what we get here? We get a plus n minus 1 upon 2d upon capital A plus n minus 1 upon 2 and capital D. This is equal to 5n plus 4 upon 9n plus 6. Look here, this is the equation 1 we will say. Now what we have to find? Find the ratio of their 18 term. So 18 term of first AP upon 18 term of second AP, and this is, we can write a18 upon a18 dash equal to a plus 17d upon capital A plus 17 capital D. Look here, we compare this. Here place of n minus 1 upon 2, we want here 17. So look here, we solve, we get here n minus 1 equal to 34, and this implies n equal to 35. So look here, this put in equation 1. Okay, this value we put in equation 1. We get a plus n minus 1 upon 2, we can write here 17, and here also capital A plus here 17 capital D equal to, place of n we put 35, 5 into 35 plus 4 upon 9 into 35 plus 6. Look at a plus 17d and capital A plus 17d. We have the terms here a18 upon a18 dash. Okay, and we solve these, we will get here 179 upon 321. All understand this? This is our answer. Now we have to find the ratio now. So ratio of the 18 term, we can write here ratio of 18th term equal to 179 ratio 321. All of you understand this? Next question is, if the sum of p term of an AP is equal to the sum of first q term, then find the sum of first p plus q term. So here this AP is given. We will suppose the first term is A and common difference is D. Now in question given that sum of p term equal to sum of q term, and we know that Sn formula is n upon 2 2a plus n minus 1 and d. So according this formula, sum of p term will be p upon 2 2a plus p minus 1 and d, and sum of q term will be q upon 2 2a plus q minus 1 and d. Now we open this bracket. First we can cancel this 2 and 2 and we open the bracket. We get here 2pa plus p into p minus 1 and d, and we get here 2qa plus q into q minus 1 and d, and these all we transfer in one side. We get here 2pa minus 2qa plus p minus 1 d minus q minus 1 d. This is equal to 0. From these we can take common 2a, so we get here p minus q, and from these we can take d common and we open the bracket, so we get here p square minus p minus q square minus minus plus q, and this is equal to 0. So we get 2a p minus q, and here p square minus q square we write near, minus p plus q we write here, and d equal to 0. 2a p minus q plus, here we can write this p minus q and p plus q. From these we can take common minus 1, so p minus q, and bracket close and equal to d and equal to 0. Now 2a p minus q, from these we can take p minus q common, so we get here p plus q minus 1 and d equal to 0. From these two we can take common p minus q. P minus q common means 2a plus p plus q minus 1 and d, and this is equal to 0. Look here p is not equal to q, so this will be not equal to 0. So we have 2a plus p plus q minus 1d equal to 0. Now what we have to find? We have to find the sum of p plus q. Sum of p plus q formula is p plus q upon 2 2a plus p plus q minus 1d, and look here, value of this is 0, so we can write here p plus q upon 2 and into this is 0. By this we have the 0, so this is 0. The sum of p plus q term is 0, so we can write here sum of p plus q term equal to 0. All of understand this? This is answer. Sum of first p, q and r term of an AP are a, b, c respectively. Prove that a upon a q minus r upon p, b r minus p upon q, c p minus q upon r equal to 0. So look here, we will suppose here AP, and first term is capital A and common difference is capital D. Now sum of p term is p by 2 2a plus p minus 1 capital D, and this is equal to sum of p term is a, sum of q term is b, so q upon 2 2a plus q minus 1 and d, this is equal to b. Sum of r term is r upon 2 2a plus r minus 1 d equal to c. Look here, this we can divide by p, so we get here and open the look here, open the bracket, p we transfer to right hand side, we get here a upon p A upon P, and we open the bracket, we get here capital A plus 1 upon 2 P minus 1 and D. Similarly, we get here in the second, this Q we transfer, we get here Q B upon Q, and here we get we open the bracket, we get A plus 1 upon 2 Q minus 1 and D. Similarly, here we transfer this R, so we get C upon R, and here we get capital A plus 1 upon 2 R minus 1 and D. These value we will put in left hand side. Left hand side is A upon P Q minus R, P upon Q R minus P, C upon R P minus Q. Here put the value, all these value we put. Place of A upon P, we can write this, so we get capital A plus 1 upon 2 P minus 1 and D, and Q minus R, plus B upon Q, we can write capital A plus 1 upon 2 Q minus 1 and D, and R minus P, and place of C upon R, we can put here capital A plus 1 upon 2 R minus 1 and capital D, and P minus Q. Look here, with the A we have Q minus R here, with A we have R minus P, and with the A here P minus Q we have. Now look here, we have 1 upon 2 and D, 1 upon 2 and D. With this we have here P minus 1 into Q minus R, and look at 1 upon 2 and D, we have here Q minus 1 and R minus P, and 1 upon 2 D with we have R minus 1 and P minus Q. Now look here, this Q and Q cancel, P and P cancel, R and R cancel, so we get A into 0, 1 upon 2 D, and here we multiply, we get here PQ. This we multiply minus PR, multiply minus Q plus R, we multiply by Q, QR, multiply this PQ minus PQ, minus R and plus P. R, P, PR we have, QR minus QR and minus P and plus Q. Okay, and look here, this PQ and PQ, this cancel, minus PR and plus ER cancel, minus Q and plus Q cancel, plus R and minus R cancel, plus QR and minus QR cancel, and here this P minus and P plus is cancel. So here all these are cancel, means we have this is 0, means 0 into we do, you will get 0, so that is equal to right hand side. All of you understand this? The ratio of sum of m and n term of an AP is m square ratio n square, so that the ratio of mth and nth term is 2m minus 1 and ratio 2n minus 1. So look here we write AP. First term is A and common difference is D. Now ratio of sum of m term upon sum of n term, and this is will be equal to m by 2 2a plus m minus 1 and D, and upon n upon 2 2a plus n minus 1 D, and this is equal to we have m square upon n square. Look at this, 2 and 2 we cancel, and m we transfer, n we also transfer, we get here 2a plus m minus 1 D upon 2a plus n minus 1 D equal to m square upon n square. Look at this, m will be in denominator and n will be in numerator, this one n cancel, one m cancel, and these terms we divide by 2, we get here a plus m minus 1 D upon, and here also a plus n minus 1 upon 2 and D, and this is equal to m upon n. Look at this is equation 1, and we will find the AP term, upon a q term. P term is a plus p minus 1 and d, and q term is a plus q minus 1 d. So look here we will compare this, and we write here m minus 1 upon 2 equal to, we write p minus 1, so we get here 2p minus 2 and 1 we transfer plus 1, so we get m equal to 2p minus 1. And here we suppose n minus 1 upon 2, n minus 1 upon 2 we write here q minus 1, so we transfer these, we get here n minus 1 equal to 2q minus 2, and 1 we transfer, we get n equal to 2q minus 1. These value mn we will put here, we get a plus p minus 1 and d upon a plus q minus 1 and d, and this is equal to, place of m we have to write 2p minus 1 and here 2q minus 1. This is our ap term and this is aq term, and we here 2p minus 1 upon 2q minus 1. And look here, this p we can write here, replace p by m and q by n, so we get here a m upon a n, and this is equal to 2m minus 1 upon 2n minus 1. So these only we have to prove here. All of you understand this?